boys and girls. Last week we made our forest chart and we made connections between multiplication and division. This week we're going to have the same learning target, making connections between multiplication and division, but now we're going to be thinking about it with arrays. Remember, a rectangular array is a group of equal size squares organized in rows and columns like a chessboard. So here is a rectangular array. You've got rows going across and you've got columns going up and down. So we're going to use arrays as a tool to help us picture what's going on with multiplication and division problems. So I'm going to build an array that matches the chart we made from last week. I'm going to act out and model the row that had 3 cats and how many legs. So we're going to imagine that every square in this array is 1 cat leg. So there's 1 leg, there's 2 legs, 3 legs, and 4 legs. 1 cat has 4 legs. But I said we were going to do the part of the chart with 3 cats, so I need to make mine a little bigger. Here's the second cat. And here is the third cat. So you can look at that in 2 different ways. You could see it as, here's a cat, here's a cat, and here's a cat. And there's a cat meowing off the camera. Here she is. Hi. She's hungry. It's almost dinner time for kitties. So, looking back at our array, each column stands for a cat because each cat has 4 legs. So, the columns, 1, 2, 3 columns, are the number of cats. The rows are groups of legs. So this could be all of the right front legs, the left front legs, the right back legs, and the left back legs. So you could even group them as here's the front legs and here's the back legs. And if we go counting across, we have the number of legs. Excuse me, going down, that's the number of legs because 1, 2, 3, 4 legs on each cat. So, to review, when we make the array, we've got the number of cats, 3 going across, and we've got the number of legs on each cat, which is 4, right here. All together in the middle, that's how many legs there would be on 3 cats. There are 12. 4, 8, 12. 12 legs all together. So, this should be reminding you of when we were doing area equations, because we just multiplied the number of cats, 3, times the number of legs, 4 legs on each cat, and we got the space in the middle, 12 altogether. So it's pretty straightforward to see where the multiplication is in this problem. But how could we use this array to show a division situation? Maybe a division story problem. Take a minute and think about that. Where would the division be here? So for division, you'd start with the total and then make it into groups. Now, when I go into a room and close the door, the kitties like to wait on the other side of the door because they just like to be in the same room as me. And if I peek under the door, I can see their little feet. So let's imagine we peeked under a door and saw 12 cat legs. We know that there's 4 legs on each cat, so 12 legs divided into groups of 4 gives us 3 cats in all. So to use an array to think of division, you start with the total and you make it into groups. So now we're going to use the array strategy to solve a story problem. Here's the problem. Yesterday, a group of children went to a party. There were balloons everywhere. The children counted 36 balloons in all. When they split the balloons equally between all the children, each child got to take home 4 balloons. How many children were at the party? Well, first of all, we need to write an equation that matches this problem. So it started with there were 36 balloons that they counted at the party. And then it said that when they split the balloons equally, every child got 4 balloons. So when they left, they had groups of 4 balloons. I'll draw a balloon. Now, we know that this is a division problem because we are taking a big number and splitting it into equal groups. And our mystery number is how many children were at the party. So you can solve this by making an array of 36 and making groups or columns of 4. I counted out 36 of these black stones, and I'm going to organize them into columns of 4. So here is one group of 4 that one kid could take home with them. Now I'll just take the rest of the stones and make them into more groups of 4 until I've used them all up, and then we'll know how many children were at the party. All right, so I've taken all my balloons and I've made them into groups of 4, columns of 4. So I've got a rectangular array and here are my groups of balloons. These are the balloons. The balloons are in groups. So there's 4 balloons in every group. And now we can see how many kids were at the party by counting up how many groups of 4 we made. There were 9 kids at the party. So, by taking our large number and dividing it into groups, then organizing it into a rectangular array, we were able to easily see how many kids there were in all. And you can use this rectangular array strategy for any division or multiplication problem. You just need to know what equation you're working with to get started. So, let's take a look at the practice pages for this week so that I can walk you through any tricky spots in the directions. Move my gems and get my Bridges book. So, we're going to start with page 153. On this page, it has rectangular arrays drawn, and it says label each array below with its dimensions. Dimensions is the math word for how many across and how many down, how tall and how long. The first one they did for you, it's 4 squares high and it's 6 squares across. Then it wants you to write the whole multiplication and division fact family. So the 2 multiplication facts that match that array and the 2 division facts that match that array. Do that for the rest of this page. The other page you need to do this week is page 155. The first part starts out very similar. They gave you an array with its dimensions. You write the fact families. Down here, there are multiplication problems for you to figure out the missing numbers. Some of them, they've given you the ending number, but they're missing one of the beginning numbers. You might need to use your fact family knowledge to figure it out, or use division to solve multiplication. If you take that 50 and you make 5 equal groups, how many would be in each group? Same thing if the mystery box is in this spot. If you had 15 and you needed to make 3 equal groups, how many groups would you have? Or maybe you could think about it, you have 15 of something and you're going to have 3 in each group. How many groups would you have? The last part of this page is probably the trickiest spot. There are 3 equations here for you to solve, and they've got adding, subtracting, and multiplying in them. They also have parentheses. Whenever you see parentheses in a problem, that's a clue to do that part first. So on this first problem, I would start by solving 2 times 4. Whatever the answer to that is, I would rewrite the equation and then start at the beginning and work my way across. In fact, let's do this one together. Grab my pencil or my pen. So 2 times 4, 2 groups of 4 is 8. I'm going to rewrite the equation 16 plus 20 minus 8. The 8 takes the place of that whole part with parentheses. Now I'm going to start at the left and work my way to the right. 16 plus 20, that's 36. So now my equation looks like 36 minus 8 equals something. I'm going to stop there because I know that you guys can figure out 36 minus 8 on your own. These are the problems that I would expect us to be practicing during our Google meetings this week. Hop in and ask, we can work on them together if you need to. So that's all for now. I will see you in our meetings, or I will see you in the next video.